So hello friends, welcome to my channel Concept with Clarity 1. In this lecture we will discuss about CMOS Logic Family and CMOS Inverter. Okay, so first of all, before discussing CMOS logic family, first let us know what is a logic family. Okay, first let us understand what is the concept of logic family. Okay, so in the broad sense, like electronics and communication engineering in ECE engineering, right? So in electronics part, we have analog electronics and digital electronics, right? So in analog electronics, basically what we study is we have the basic building blocks in the basic analog devices are: one is diode, the second one, the active devices are diode, transistor and FET, right? Whereas when compared to digital, when coming to digital, the basic building blocks are logic gates, right? So analog electronics is all about the basic building blocks like diode, transistor and FET, and the circuits constructed by these devices, right? Analog devices diode, transistor and FET, and the circuits constructed by using these diode, transistor and FET. Like the circuits constructed by diode is clippers, clampers and all, and by transistors is amplifiers and switches and all, right? Whereas in digital electronics, all the circuits are made up of logic gates, right? So if you see, analog is existing in nature, digital is man-made, right? So what does this mean? Analog is existing in nature and digital is man-made, right? So though you have digital devices like logic gates and you are constructing some circuits using logic gates, right? And also we have some combinational circuits which are constructed by using logic gates like multiplexer, decoder, comparator, multiplier, right? Whatever logic gates, with the logic gates we are constructing, even combinational logic circuits and sequential circuits as well, like which have the memory. Even that memory is a group of registers, register is a group of flip-flops, and flip-flop is a 1-bit storage device which can store either a single 1 or a single 0, right? So even that flip-flop is also again constructed by using logic gates only, right? But here, coming back to here, analog is existing in nature, digital is man-made, right? So whatever the signal you have, okay, initially that signal will be analog, right? Like I am speaking, that's a speech signal, right? When I plot this one, this is an analog signal, okay? So this analog signal is converted to digital by using an analog to digital converter, right? Analog signal, digital, right? And at the after sending this signal, right, again you convert back into from digital to analog at the receiver, right? So so ultimately why we go for digital, we have multiple advantages with the digital processing and all, right? So that is why that's the reason we go for digital signals, right? We convert our analog signal to digital one, right? So like I told you, whatever logic gates we have, what are the logic gates we have? NOT gate, okay, AND gate, OR gate, basic gates, and the other gates are made up of these basic gates, right? The symbol of the AND gate, NOT gate is NOT gate, okay. So AND gate is an 2 input gate, okay, and OR gate is again a 2 input gate, right. So though we talk about the input is 1 here, then the output is 0 or for an inverter, right. And if I give A and B as the inputs to an AND gate, then A into B is the output for an AND gate, and if I give A and B input to the OR gate, then A plus B is the output, right. So though we are talking about ones and zeros in the digital signals, internally this logic gates, internally logic gates are designed using transistors only, transistors or FETs only, right. So internally logic gates are designed by transistors or FETs. Okay, we can also use diodes as well, but we don't use that here, right. So implementation of logic gates, right. That means the internal structure of any logic gate by using transistor or FET or diode is called as logic family, right, is called as logic family, right. So this is logic family. So what does a logic family do? A logic family implements the logic gates. Okay, so there are different types of logic families. One is CMOS logic family, second one TTL logic family, and the third one is ECL logic family. Okay, so in this CMOS logic family is designed by using PMOS transistor and NMOS transistor, right, and that means my FETs, whereas TTL and ECL logic families are designed by using BJTs, right. So we will discuss about CMOS logic family. Okay, we will discuss about CMOS logic family. CMOS logic family is implementation of the logic gates using CMOS transistors. CMOS transistors. Okay, what is a CMOS transistor? CMOS transistor is a combination of a PMOS transistor and an NMOS transistor. CMOS transistor is a combination of okay. So you see here it's a combination of, one is PMOS transistor, this particular transistor is a PMOS transistor, and this particular transistor is NMOS transistor, right. So you see this PMOS, how this PMOS will be behaving. For a PMOS transistor, if input is equals to 0, then PMOS will be on. Okay, if the input is equals to 0, then PMOS will be on. Similarly, if input is equals to 1, then PMOS will be off. PMOS will be off, and vice versa for NMOS, right. So for an NMOS transistor, if input is equals to 0, NMOS will be off, and if input is equals to 1, NMOS will be equal to on, right. So, you see here, now we will see the action of a simple CMOS transistor. CMOS transistor, you see the connections here, one PMOS transistor and one NMOS transistor, both the gates are connected and given as the input, and you collect the output from here, right. So, we will see the action, right. So, I will take a table here. So, we will add rows and as well as column. Right. So, you see here how this acts. So, we will take okay. Okay, we will take this one. So, we will take input PMOS, NMOS transistor and output, right. So, if input is equals to 0, 0 means 0 volts, right. In reality it will be 0 volts, right. For 0 volts my PMOS transistor will be on and NMOS transistor will be off, right. And since this is on, PMOS is on and NMOS is off. So, this will be open circuit, this transistor will be open circuit and this will be short circuit. So, my VDD will be flowing to V out. VDD is nothing but plus 5 volts, plus 5 volts is represented as a 1 here. Similarly, if the input is equals to 1, if the input is equals to 1, that means for a plus 5 volts, here my NMOS transistor will be on and PMOS will be off. PMOS is on, NMOS is on, PMOS is off and NMOS is on, right. So, what happens? So, this is open circuit now, right, this is short circuited. So, what happens? The short circuit, because it is short circuited, my V in will be flowing to the ground, hence my output will be equal to 0. Whatever V in is given, that is going to ground, hence my output will be equal to 0. So, what we observed is a simple CMOS transistor. CMOS transistor is also called as CMOS inverter, because when my input is 0, my output is equal to 1. When my input is equals to 1, my output is equals to 0, right. So, simple CMOS transistor is equals to CMOS inverter. I hope you have understood the CMOS inverter concept and CMOS logic family basic. So, if you like the video, if you understood the concept, please like the video, share and subscribe. Thank you.